what would the parent function be of this thing?
Y equals X squared.
Yeah, if you see a parabola, that looks like a y equals x squared. And there are basically, well, we're going to start off with two different things that we're going to do to this. And so the first thing I can do is I can do things on the inside of the square and I can do things on the outside of the square. And so if I add 3, how's that going to change this thing?
Shift it up 3 units.
Yeah, shift it up 3 units. And if I do a minus, how does that change things?
It's
Right.
down. It's down 3 units.
Then we're going down 3 units, right?
Yeah.
So that's happening on the outside of the square is what I'm hoping that you're seeing, right? We're not squaring that 3 on the outside. We're not doing anything with the square with that 3, right? The 3 does not get the square treatment. If, and I want to ignore this for a second. What if I start doing things on the inside like x, I don't know, -2 on the inside? How does that change?
I think you said something, it does not exist. Was that? No, that's the plot. That's the
Yeah, it's the
negative.
same thing.
Shift left.
Yeah.
So when you see -2, you
Side
might
left.
think this thing shifts left, right?
You look to the right.
But it does kind of the
Good
opposite of like what you might.
We're all guessing.
So -2 is going to end up shifting this thing to the
To the right.
To the right.
right 3
Yeah.
units. And if I do a +2, that's going to be the thing that shifts it to the left. So whether I'm doing it on the outside or whether I'm doing it on the inside of the function is something you got to take note. If I do it to the outside, it's just moving the whole y value, right? It's moving it up or down. If I do it on the inside, it's happening to the x value, but it's happening kind of different, probably the opposite from what you would like maybe intuitively think. So if I add 2, I'm going to the left. If I subtract 2, I'm going to the right.
So just to clarify, it'll always be that way, right? Where every time one way will go to the left and the other way is to the right. Like it doesn't change over time.
No, that doesn't change. And like part of this reasoning was like, if I have like a 0, 0 here, I want it so that when I plug in 0 to my f, I'm going to end up getting a 0. And so in order to do that, I have to make my x +2 equal to this 0 over here. Maybe I could have picked a better point that was nothing but zeros. But when I go and plug a x equals a -2 into something that looks like f of x +2, I'm going to end up keeping that 0, 0 point. I guess it goes -2, 0 now, right?
Yeah.
So it has to do with that we're plugging this thing into the function now. And so my new x is my old, this new x has to be matched this old x that was plugging into the function originally, which was 0. And in order for those things to match, you have to do a little bit of back solving, like right in here. And so when we back solve, we're doing the opposite of what we did. And so that's where the sort of opposite thing is coming in, is that there's a bit of back solving in there to find what the original x should be. Any questions before we go to groups? Because I want to go through 1, 3, 5, and 7 are kind of like in this ballpark. We're using, I think, these mainly just these 2 principles. So 1, 3, 5, 7. We have like 4 of them that are basically the same sort of principle here. And then I think we get 4 more that are pretty close to the same principle. That's multiple gas matching. 9, 10, 11, 12 will be the next ones that I want to go through. So let's start with 1, 3, 5, 7. Let's open up breakout groups. No. I'm looking at this first graph. What's the parent function here?
X squared.
Yeah, it should be an x squared. And so then I talked about it, but I could have something inside, I could have something outside.
So you're not moving up or down, so you wouldn't have anything on the outside. So on the inside of the parentheses, you would have +2 because you're moving to the left.
And on the inside, I have a +2. This thing moves to the left too. And you might think I'm moving to the left. I know that's getting more negative, but this thing is like kind of the opposite of what you might intuitively think. So it should be x +2.
Yeah, x plus the square.
So x +2 squared. X +2 in parentheses. That whole thing being squared.
You lost me. How did you get the x +2 squared? Because I thought that we were only supposed to do the parent function, which is y equals x squared. So are you just doing an example of what it could look like?
I think the instructions say to find the graph, right? Write the equation of each graph. And then they give you the parent function. So the parent function you do have to figure out.
Oh,
they want the
oh, okay.
Thing. Yeah.
Okay, I see that. I see it now.
And so if we move left 2, it's going to be a +2 on the inside.
I thought it was a.
Okay. So that is 1.
And you flipped it to make it a +2 because it's at -2.
Yeah, so if it's going left, it's going to end up adding. If we go right, we're going to end up subtracting. And who's next? Fernanda?
Would that one be y equals.
What's the parent function? Just start with the parent function.
X +3.
I knew it was too easy.
Yeah, but
For some reason.
what's the parent function here? Is it a square? Is it a square root? Is it an absolute value?
Square
What is
root.
this like? This is square root.
Yeah, it's square root.
Alright.
And then the +3 or no?
Can't see people. Okay, there we go. X, and you said +3, and why did you say +3?
Because it's going to the left.
To the left. And is that +3? Should I write it like that, or should I write it like, just so we're all on the same page? Should I write it maybe like that? Which way is it?
The first one.
Which one?
The first one.
The first one. Yes, yes. It should be like this, right? Don't do this.
Okay.
That would move it what, up 3, right? If I put it on the outside like that.
Yes.
Yeah.
It would.
Yep. So I'm making sure we know what it looks like on the inside of the function versus the outside of the function. Some people, I think, get confused on that concept.
Mm-hmm.
So I know I'm probably asking you stuff you know or something, but just making sure. All right, 1, 3. The next one is number 5. What?
I have a question. For number 3, when you said that it's going right, that means we have to add. And when you say it's going right, you're talking about the arrow, right?
This thing is going left 3 from what it usually is. So when we look at the normal like square root function, it's usually right here on the 0, 0 and makes that little shape coming this way.
Okay.
And so we move that thing. Yeah, we moved it to the left 3 to get it to start at -3, 0 instead of 0, 0.
Okay, so I was kind of getting both of them backwards because I was looking at the arrow, but I need to be looking at, okay.
Where it started, yeah. Where that point shifted.
I have a question.
Yeah.
Sorry, hold on, I'm clarifying. Oh, never mind. I misunderstood. Oh, okay. So So you're adding 3 and that's the square root of x that has the equation. So I see that, but I wanted to make sure. So it moves the opposite way, correct?
Yeah, so this is left 3.
Okay, just want to make sure. Okay.
So we took the square root function and we shifted that whole thing left 3 units. It usually starts like right in here and goes like that, right? It's usually what it looks like, something like that. Okay. These are weird. I know they're weird. And I know you heard me probably say this enough, but I'm going to probably say it once more. Like, you have to practice this stuff a bit, right? To get it. I've been doing this stuff nonstop pretty much since I graduated high school. So, what's that, 15 years? Close enough. So, I've been doing this year after year. So, I know I'm like probably really quick, but it's because I got a lot of practice. Got a lot of years of practice. Who's next? Kayla? What would you say the parent function of this thing is?
Y equals, I forgot what it's called, the lines.
The lines, yes. Absolute value, right?
Ready.
And
That
then
is an absolute value of X. So I could have stuff on the inside, I could have stuff on the outside.
X plus 2 in the inside.
So if we think about the original one, let me draw it on there just so people can see it. Like the original one's going to go through like 0, 0, right? Y equals
Plus 3.
absolute value of X. And so I think you said it. If I move it to the, what was that, left 2?
Nice.
What should be on the inside? Kayla, you still there?
Yeah.
So if I move it to the left 2, what should I put on the inside here?
You got it. Do it, Kayla. You had it right.
Yeah, I think you said it right.
Oh, I said it right. Oh, plus 2.
Plus 2, yeah, that's it. I was like, where
I
you
thought
at?
it was a ball.
Oh, you said it? Okay. And then the other thing I have to do is what? I'm going to move it to the left 2
Shift it down.
And
and
down
shift
1.
it down 1. So down 1 is a -1 on the outside. Yep, that's it.
Okay, I have a question.
Mhm.
What if I put X minus 2? Because I thought whatever is in absolute value, we change it to positive.
If it's an absolute value, you're going to take this thing and evaluate it. And then after you evaluate it, you would make it positive.
Oh, okay. See?
So we could still have subtraction within an absolute value, or we could have addition.
Okay, gotcha.
Like, throw some numbers in there if that's like confusing you, right? Do 1 plus 2 versus, I don't know, 1 minus 2, right? We can do subtraction within absolute values. That's the thing, right? Y'all can do that with these sorts of things too, right? That's, and if I'm being honest, if I had like a graph with a bunch of transformations on it, I'm probably not going to go like try to figure out like 5 different transformations in my head or something, right? I'm probably going to use some technology and like double check what I'm thinking. All right, number 7, where are we at? That's the first group. Did I call them? No, I skipped people. Ooh. Jade. What's the parent function here?
Great question, to be honest. I am having trouble with this. So I was trying to work it out myself, but I knew that we were going to go over it. So I was kind of hoping that you and I could kind of like work on it.
Good deal. There are, I think, 3 parent functions, right? The square root, right? I think we went over that one.
Yes.
Not square root, square, sorry.
Absolute value.
Absolute value. So how does that differ from square? Sorry, I keep saying the wrong thing.
You're not squaring it or square rooting it at all. It's like
But
that.
like graphically, like this one
Yeah.
got some curves there, right?
Yeah.
This guy, he is straight and pointy, right?
Yes.
So like graphically, the main thing that like differentiates like an x squared from a absolute value of x is like this guy's a curvy parabola, this guy is pointy. And then the other thing, the third thing is this guy. And I would try to get familiar with these graphs a little bit, right? If I do absolute value of x, do a t-chart if you have to. You can pick some values. But basically, if I throw a negative in there, right, it's going to end up giving me a positive. I'm going to get 0, 0. I'm going to get 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. If I do this absolute value, right, if I do a square, getting at like the square pattern will really sort of help you, right? -3, 9, -2, 4, 0, 0, 1, 1. Knowing that I can go over 1 and up 1 and get another point, right, is a good sort of strategy here, especially when I start shifting things. Getting these patterns down will really help you. I can go over 2 and I would have to go up, what, 4? I can go over 3, I would have to go up 9. These things are symmetric, right? So we can use those like symmetries to help us graph this thing a little bit. So I'm hoping you'll start to notice these sort of patterns in these parent functions as well. We're going to use them a few times.
Sorry, did you say that it was like the parent function that's x squared, that's the one that's curved? Or the square root, sorry.
So when we do the square function, that's a parabola. So it's curved like this, like a U, or if it's flipped, right, it's curved like a N or something. I don't know. Upside down U. Happy face, frowning face, right? One way or the other. But it's curvy. The square root looks maybe similar. It's also curvy, but we only get like half of this, right? It's like we're taking that parabola and turning it on its side. We're swapping our x's for our y's and our y's for our x. So if a parabola looks something like this, which is a square root is going to look kind of the other way. But we're only getting like the positive portion.
Teacher, I noticed something like if it's the parabola, it's going by the y-axis.
Yeah,
if you
throw the negative root in there, right, you get the whole parabola, right?
Yes, and if it's the root, it's going by the x.
You get the parabola on its side, right? Yep.
Yes, it's the symmetry for the x-axis.
Do we ever show them how to do this with a table?
I'm pretty sure we did these things with tables, like when we started graphing things.
Like the shifts, I mean, the transformations.
I haven't gotten to that yet.
Oh, okay. All right, just checking.
I did that in the notes, though. That was in their notes where we do the table and sort it out with the table. All right, so the parent function of this is what?
Number 7?
Yeah.
I think it's the root square x plus
Square root of x.
Yeah, it should be square root of x, right? It's looks like the parabola on its side that fell on its side. So this is definitely a square root. I can have things inside my square root. I can have things outside my square root. So what did I do to my square root? My original square root goes through 0, 0. Another point is 4, 2. And so I think it goes something like that, the original one. Maybe a little more curvy here, but.
It's -2 inside of the square because it's going the left.
So we're going left 2. So what should I put inside of the square root?
+2.
This should be a +2.
2, yes, sorry.
And then I also went down
with -3.
3, so I have to put a -3. I'm running out of room here. And that should be on the outside. I should probably write this so it looks a little bit cleaner. So I have a +2, and then I have to make sure that is on the inside of the square root. And I have a -3 on the outside. And so this tells me what left 2 and what down 3 is what this is telling me.
Shifted by 3.
Questions about this? I think so far we're moving up and down, left and right. I think there's one other thing they go through in here, and that's what flipping them. But I don't think the next 4 have that in there. I could be wrong, but I think 9, 10, 11, and 12 are kind of the similar sort of concept as this. And so I want to give you all a few minutes. I'm probably not going to give you all quite as long, maybe. Are there any questions about these 4 we did? I said it, but let's just like, right? Like one of the wonderful things about math, right, is like you don't have to believe me. Do you want to continue? Yes. Okay. It really is, right? You can see things for yourself. You don't just have to like blindly sort of follow an authority figure. It's one of the great things. But Desmos, that's what I was trying to do. You can do stuff in Desmos, right? If you this thing is stuff is confusing you, we can do what, like x squared. I don't know. And then if we add 1, right, it's going to move it up 1. You can play around with these things on your own and see these sort of properties. I know it's what you're all dying to do, but if I do subtract, it's going to move it to the right. If I do an add 4 inside, right, it's going to move it to the left. You can even do like variables in here. And you can do like some animations if you get really bored. You can animate variables. So whether I'm doing a -c out here, a positive c, if it's positive, it raises it up. If it's a negative, it's going to go below, right?
Yes.
You can do the same thing on the inside, add a slider, right? You can start some animations. Okay. Where's my stop share? There's my stop share. Desmos is a really good tool. It's a really good graphing software. It's what I use quite often. So what numbers do I want to do? 9, 10, 11, 12, multiple guess, right? Okay. Any questions before we get to breakout rooms again?
We said 19, 20, 11.
9, 10, and 11.
9, 10. Okay, thank you.
Yeah,
Sorry.
it should be like 4 equations and 4 graphs that you match to the equation.
Yes. Yeah.
And so I know like 10 and 12 probably aren't like in that list of homework that you're supposed to do, but it's multiple guess and it's probably easier to match things up than it is to just leave 2 guys by themselves. So go ahead and do them, right? Deanna?
For 31A.
Yeah, 31A. So if I do f of x plus 2, how does that change my x values? Maybe that's a weird question. Do my x values change?
Yes.
What does the plus 2 do to it?
I followed the graph, the equation, I guess, and I just went up 2 on all of them.
Okay, so if you did it on the graph and you went up 2, I think you would move that point up too. And so what does that point become? Because you could probably do this, it's like one shift, right? And so you could probably do this thing.
Excuse me, which number are we on?
This is 31A.
Oh, okay. I was confused. I was wondering what was going on. Okay. Okay.
So if I
that
move,
would be -2, 4.
and so you could probably, like I said, you could probably do this one, like just looking at the graph, moving everything up too, because you're doing one transformation, right? And then like that's kind of easy to do one transformation, but we start getting multiple transformations in here, things might start getting a little harder. So I want some sort of maybe more solid way to get there than looking at a graph. And so if I'm doing that, f of x plus 2, how did that change -2, 2? What did I do to get to -2, 4? I'm adding 2 to which quantity?
To the x.
Oh, the x is -2 and it stayed -2.
To the y, I mean.
To the y value, yeah. So the x's are staying the same, right? We're not shifting it left or right. We're just going up and down. We're going up 2. And so if I want that, the 0 -2 should become what point? So instead of 0 -2, we're going to move it up 2. And what point is that?
0, 0.
Yeah, 0, 0. And then the last thing is this thing is what point?
It's 2, 4.
2, 4. And so your new graph should look something like this. The same thing, but shifted up 2 units. If you want to give me the points, you should be able to give me the points for each of these things. -2, 4, 0, 0, right? And then what, 2, 4? So we're adding 2 to each y quantity when we shifted up 2. Let's step backwards without deleting everything. I wonder if I can do enough.
Do we need to write the ordered pair next to our dots or just graph it correctly?
It might help me if you get the, like, if you're graphing the wrong point and you put the right number, you might get partial credit for that. I would suggest doing it because it's not a whole lot of extra work and it would help you in the long run. And so I think I'm done with this, trying to keep my skeleton up in there without deleting everything. Okay. And then what is the next thing I have to do? The next one was what, f of minus f of x? Is that what we're doing?
Yes. Which one is B? 31B?
C, I think, is what I did next, right?
Yeah, 31C.
Yeah, so we're doing minus f of x.
Oh,
So is that changing my x quantity or my y quantity?
Your Y.
The y? Why do you say that? Because f of x is just like
Because
y,
it's
right?
supposed
F of x is giving us the y quantity. So we're taking this y quantity, and what do I do to my y variable?
It needs going to be down.
I think I know what you're talking about. But what am I doing? So instead of a minus
Reflecting.
2, I'm reflecting about
About -2.
So who's next? Fidel, did you get this one?
I was actually having a little trouble on this one. So if they say reflect, that would just be, so for like the -2, it'd be 2, right? Since it's reflecting.
We want to reflect the y quantity. So if this y quantity is at 2,
okay. So it'd be -2.
yeah, so that should become -2, -2. If I graph that, that's what, this point down in here?
Right.
And
So you would do nothing to the x, or you would make it negative automatically.
So we're not doing anything to the x, I don't believe, right? We're just flipping it. Going 1, 2 here. I have to go another 1, 2 here.
Okay. Right. Yeah. So 2, the other one would be 2, -2.
This one would become 2, -2. So we're
Right.
flipping these two things.
Oh, we're doing it right.
And then what about this thing? We hadn't flipped this guy yet.
That would be 0, 2.
So the negative becomes positive. So basically we're tacking a negative onto our y is what this thing tells me. I'm doing like a negative y value, right? So if it's positive 2, it's going to become negative 2. If it's negative 2, it's going to become positive 2. Same thing with this. If it's positive 2, it becomes negative 2 over here. Make sure you got that negative in there. And so I think I have, let me erase some of these extra squiggles I got in here. Oh, not that many.
Excuse me, teacher. We are doing the 31x, right?
31C is what we're doing.
Yeah, 31C. And then this it's the same thing with the first one. It's just we need to flip the whole thing down.
So everything gets flipped.
And our excuse me, and our vertex it's going to stay the same one, 0 minus 2, right?
So that thing's going to flip as well, right? We're going to have this thing is going to add positive 2. These things are going to flip down to -2. Is that where I'm going?
Yes.
And then this thing is at -2. It's going to flip up to a positive 2. So this thing should be flipped. We're flipping it about the x-axis. So my new points are -2, -2, 0, 2, and what, 2 minus 2?
Because me when I flip it everything down, it may change to 0 minus 2, -2 minus 4, and 2 and -2 4.
I think you're adding something to your y value. I think that maybe you're getting confused with the first one with A. So this is part B. So basically we're throwing a negative onto our y value. It's happening on the outside of our f of x function. It happens to our y value. So if it's a positive 2, like here, it's going to become a negative 2 like over here. Right? If it's a negative 2 like over here, it's going to become a positive 2 like this thing. And we have a positive 2 again. This thing is going to shift to a negative 2.
So when you say these things shift about, does that mean like 180 degrees backwards about face or approximately at?
So the way I was saying shift, I think it's just like you're throwing on a negative to that y, but they're reflexive about the x-axis, right? So if I'm going 1, 2 to get to the x-axis, I have to continue 1, 2 more to get to my point. So they have to be equal distance from the x-axis. Same thing here, right? I'm going up 2 to get to my x-axis. I have to go 2 more to get to the point that I'm supposed to be at. So reflections work like a mirror, right? Like your equal distance from the mirror as your reflection is. The closer you get to the mirror, you can like start touching your reflection. You can pretend like you have friends, right? Yeah.
Teacher, here the original equation which is y equals to minus f of x, right?
Y equals a minus fx, yes. F of x, yep.
But where did you get this -2 and 2? Please.
-2 and 2 were from the graph originally. I picked that point off of the graph. That was this thing over here.
Because in the original graph, we have just, in the axis, we have 2, 0, right?
The original graph had the points -2, 2, 0, -2, and 2, 2.
And 2, 2, yes. And yeah, okay.
So those are my original points. Basically, I'm going to throw a negative onto every y value that I see there to flip it about the x-axis. If it's positive, it becomes negative. If it's negative, it becomes positive. And so we're flipping things up and down about the x-axis.
Okay.
If it's up, it's going to go down. If it's down, it's going to go up. And so that flips it about the x.
Okay, we were checking it. Okay, thank you.
Okay. Questions about this one? This one was like 31C. We did 31A. We did 31C. I want to go to 35. B. So let me bring that up so I can draw that. 35A is what I said, f of x.
We should 35B.
So
Okay.
let's see, can I draw it right quick right here? So I think I have a -2, 0 as a point. I have a 1, 2, that's a point. I have 0, 0, that's a point. I have 1, -2, that's a point. And then what, 2, 0 is a point. So quick draw of the graph, and then let me write the points out. So if I have a -2, 0, I have a -1. I'm going to write them out left to right. It's probably the easiest way to make sure you don't miss them. 0, 0, 1, -2. So they're giving me 5 different points.
Yes.
And let's do, I don't know, green. Is green a good color? I know I have this function that looks like f of x plus 1. And I have a +1. All right, so this might be where you have to think a little bit backwards. So a +1 is going to shift it where?
To the left.
To the left. And if we want to move this to the left, like -2, 0, if we want to move it to the left, what would my new x value be over here?
-3.
This would be a -3. So what we have to end up doing is what? Subtracting 1 here. And then what does this +1 do out here?
To add 1, it's going to be -3, 1.
It's going to move it up 1. And so if we move this up 1, that moves my y value up 1. So I believe we're adding 1.
Yes.
So the first -2, 0 becomes what? -3, 1.
Yes.
And -1, 2. Who's next? Jerry, are you around?
Yeah, I got confused after you explained how you got -3 and 1. Like, I don't know how you got that point.
All right, so we're moving this thing. This x plus 1 tells me I'm moving it to the left, right? And so if I take a -2, 0 and I move it to the left, what is that new x value over here?
It'll be -3.
Yeah, so this, I'm moving from a -2 to -3. And then if I move it up 1 is the next step. How does that change that x value there? Or the y value, sorry. If I move it up 1, it's going to change the y value by what?
1.
Yeah, +1, right? And so this -2, 0, if I move it left 1 and up 1, it's going to become what? -3, 1? Moving it left 1 and up 1.
It's the second point, teacher.
Yep. And so if we look at how we did that, we subtracted 1 from the x and we added 1 to the y.
Yes.
And so if we keep the same pattern, -1, 2 should become what?
Is it 2, 3? Or
what kind of 2?
-2.
Yeah, it should be -2. -1, -1, -2. 2 and 1 make 3. And if we do 0, 0, it's going to become what?
-1, 1.
Yeah, so you're going to do 0 minus 1 is going to be a -1. 0 plus 1 would be what? +1?
Yes.
I'm smiling at you. That's what I think every time I see the origin. It's like some eyes staring at you or something.
You got it.
Is it apophenia where you see faces and things? I think it's like a really common human trait. The 1 minus 2, sorry, I got a little sidetracked. 1 minus 2 should become what? Jerry, are you getting this?
Oh yeah, sorry. I got for 1 minus 2, I did 0 minus 1.
0 minus 1. Yeah, that's right. We're going to subtract 1 from that. It's going to be 0. We're going to add 1. That's going to make that minus 1. And then the last one, you got what?
I got 1, 1.
1, 1 sounds good. So we're graphing these points, all of these points. I believe the first thing I graphed was minus 3, 1. The next thing I'm graphing is minus 2, 3. So minus 2, and then I'm going to go up. 1, 2, 3. That's minus 3, 1 there. This is a minus 2, 3. The next thing is a minus 1, 1. Looks like it's in here. So connecting each consecutive point. 0 minus 1 looks like it's right in here. And then 1 comma 1 looks like it's right in here. I know my graph is getting a little crammed in there. Does that look like I moved everything, what, left 1 and up 1? Left 1 and up 1, left 1 and up 1. Left 1 up 1, left 1 up 1. That's it. Questions about this?
Let's try B.
Try B, is that what you said?
Yeah.
Let's see. Okay. I'll just clear this. There's a lot of stuff. All right, so I don't know if I'm going to draw the original, but I'll draw my graph out here. I think this will probably give me enough room. I'm going to write out the points, minus 2, 0. Minus 1, 2. 0, 0. 1 minus 2. And then the last point was 2, 0.
You did the part P, teacher?
Yeah. So B is being requested. So I want to do a minus f of x. Minus 1.
Okay.
All right, so if we're plugging numbers in here and we were crunching this thing down, I don't know, throw a number in there for f of x, right? Minus what? 3 minus 1. Would we multiply by this negative? Because there's basically two things happening here, right? I think that I see there's that negative on the f of x. And then there's also this thing, this minus 1 thing happening. But which thing should we do first? I think is kind of the question that I'm trying to ask.
Reflect.
Should do that reflection first.
Down.
And if we do that, 0 is going to become what? Negative
1.
Negative 1.
So we can throw in, ooh, that's not what I wanted to do. I want to do like an eraser. If it's confusing you, we're throwing this into our y value, right? So we can throw in this y value. If you want to do this in multiple steps, you can, but we're basically doing a minus 0, minus 1 to figure out the first thing. And so that's where they're getting the negative 1 from. Same thing, second step. But now my number is minus 1, 2, so I'm plugging in what? 2? Should give me what?
-3?
1.
Should be minus
1.
3. We're going to take 2, we're going to make it negative, and then we're going to subtract 1. So I don't think we're messing with the x at all on these. I think our x is always the same. 0, 0 is going to become what? Not the right thing, eraser.
0 minus 1.
0 minus 1. So I'm throwing in 0 to this function. I do -0, -1 is giving me a -1. The next thing I throw into this thing is what? -2. So if I throw in a -2 into here,
Gonna give you a 1.
yeah, it's got a double negative now. So -2 becomes +2, and then I subtract 1. It's going to give me 1. And 0, if I plug 0 in, what am I going to get?
-1.
-1. So what this should have done, and we talked a little bit about it, but this is a flip and down 1.
And if if it doesn't have that -1, it's just a blank number. That's when we're just flipping you're just flipping the sign on the Y.
That's the flip. That's just, yeah, that by itself is the flip. This is the down 1. Yep. And so now I have 5 points I need to graph. If we graph these out, it should be flipped and it should be down 1. So -2, -1, 1, 2, -1. Make sure I got this right. That's -2, -1, -1, -1, 2, 3. 0, -1. 1, 1 is this one. And 2 -1 is, I believe, this one. So if we're looking at these, we're connecting consecutive points to get our new graph. Does that look like the original graph, but like flipped and down 1? Original graph looks something like this. Right. Down to 1 -2, and then coming back up to 1. All right, that was my original graph. Something like that. So does that look like that thing flipped and then they lowered it?
Yes.
Okay. Questions about this? This one is a bit more than the rest, right? We did 2 different things at once. We did a flip and a minus. So we did 2 different things to the Y. If you have to do them one at a time, that's fine. If you have to convert like the flip for one of them and do the minus, excuse me, 1 -1 separately, that's all right as well. Okay, so I want to go over, just share it here. It's right here. Yeah, stop sharing that thing. I want to go over this one right quick. 57, is that the next one I said? Yeah, that's it. So 57, they say use transformations to show how the graph of f can be found. My parent functions are y equals square root of x, y equals x squared, and y equals absolute value of x. Same 3 that we've been dealing with. If I look at this thing, they want you to, I think they just want you to explain how you're using transformations, right? It says you do not need to graph it. We're just explaining what's happening to this graph. So the first thing, what graph are we starting out with?
Square root, or what? Oh, sorry, a quadratic.
Not square root.
Yes.
Square root.
Let's start with the square root function, like y equals, I can't, there's not an easy key to type for that on this. So we're starting with the square root function, right? Y equals, I can do it with my pen, I guess. Let's see if I can do a square root here. You're starting with the y equals square root of x, and then what are we doing to it?
We are going left 5 times, right?
So yes, we're going left 5 units, is what they're going to say, something like that. Shift to left 5 units. Is there anything else you see there?
The negative sign.
So what does that negative sign right there do?
Reflecting it over the y-axis.
Over y-axis is what you said. So if we put the negative on the outside,
it reflects down.
Yeah,
From the axis.
It should be over the x-axis. And a little bit about that. If we look at this, right, this whole thing right in here, This is like my function. So you could call this f of x. Maybe not. That thing is already f of x. But if we wanted to call this another function, maybe g of x, right? I could just do that, maybe x plus 5. Like this is the square root thing, right? And this is on the outside of the square root thing. So I'm tacking on that negative kind of at the end. If I think about when I plug in numbers to this x, first thing you're going to do is add that 5. The last thing you're going to do after you do the square root, right, is going to tack on that negative. So that negative is coming on after we do the square root. And so since it's after we're doing the square root, this should be happening to my y values. It's outside the square root. It's outside the function. It happens to the y's. And so since my y's are getting flipped, what? The ones on top are getting flipped down. The ones on the bottom are getting flipped up. That should be about the x-axis. So I think you had it right with the reflect. Thinking about what axis it flips over sometimes is a little bit tricky. Because we are flipping the y values, but the y values flip over the x-axis.
Okay, I have a quick question about a problem similar to this.
Mhm.
If that negative sign was inside of the square, that means we cannot do the problem, right? Didn't it say something like that? Or they
They do like a negative x. I'm not sure if they're doing negative or reflections over the y, because I haven't seen any examples in here. I don't remember seeing any examples in your notes. So
Yeah,
I don't know if I think they're
Oh,
I think they're avoiding those as far as I can tell.
yeah, if I'm not mistaken, in the notes, it just said like we couldn't do that, and we kind of put like a little squiggly line and was like, you know, and we moved on to the ones that we can't do. If that makes sense. 'Cause I was trying to figure that out in the notes.
We should still be able to do this. You're flipping the x quantities, right? And so the thing with this though is that we're flipping a parabola, right? But we're flipping it over this axis. So we're going to end up getting the same thing because it's reflective across the x-axis.
Yeah, I'm
or the
sorry.
y-axis. And so if you flip this thing, it's really just x squared, ain't it?
Right, right.
No, I think what she was talking about is where you said the negative y equals negative square root, like y equals negative square root of -9 does not exist. So when it was on your lecture and it was like number 8, that was number 8 there. It does not exist right there. But what I think what she's saying is that applied to this 57. Well, does it not exist if it's the negative is on the outside?
Okay, let me look. You said it's in the lecture notes.
Yeah.
Question, what it was problem on 8 and 9?
Yeah, number 8, right there. Let me see. Number 8. Yeah. That what you're talking about?
Mm-hmm.
And you said it does not exist, but we're trying to see if it does it apply to that.
Okay, no, this has to do. I know what you're talking about now. I'm glad y'all asked then. Okay.
I know, right? Thank you, Terry. You might write it down, girl.
That's something a little different. So this has to do with
I
the
wasn't
domain.
understanding. I'm sorry.
All right, this has to do with the domain of square roots. So if I have a -1, can I do that? Which of these can I evaluate?
The 4, the square root of 4.
Yeah, 4, square root of 4 is what, 2? Can I do square root of 1?
No.
No.
What's the square root of 1? What are 2 things
1.
that multiply to 1? Yeah, that's a little bit of weird, guy. But we can do square root of 1. Can we do square root of 0? Are there 2 things that multiply to 0?
Zero.
Zero multiplies to zero. So these are okay. What about this? Can I do a negative number and square root of a negative one?
No.
Yes. It would be 1, right?
So 1 times 1, does that give me a -1?
No.
No.
Yeah, you can't.
If I do -1 times -1, does that give me a -1?
No.
There's no two things that are the same that are going to end up giving me a negative, right? Is what we're trying to get at here.
Okay.
So if these are the same sign, they're going to end up giving me a positive, basically. This thing is undefined. We're not defining it. When we get to, I'm gonna like go ahead a little bit. Imaginary. Right? When we get to imaginaries, we'll talk about those and we will define these things as imaginary, but we're not quite there yet. So these things are undefined. There's no way we can graph that. Even if it is imaginary, we still can't graph it. So,
okay, but what about number 8 though?
So number 8 was this one. So when we're looking
Well,
at
it was that one, but this one, the negative is on the outside.
So yeah,
it's
so looking
y
at this
equals
one,
negative.
So looking at this one, the reason why, like I want to highlight real quick, the reason why like all these right in here are black is because we can't evaluate this thing at -9, right? We can't evaluate this thing when we plug a -4 in there. We can only evaluate it starting at like 0. Square root of 0 is 0. So that is this one, and this is the parent function that we're talking about. So now if we want to go the other way, hopefully I said the right thing in the notes. I'm pretty sure I did. If we do y equals a minus square root of x, the minus is on the outside. So can I plug a -9 into my x over here? What happens if I plug -9 in there? Do I get a result?
It'd be -3, wouldn't it? It'd be +3 if you.
We're looking at this right here, right? This, just ignore the negative on the outside and look right here. If I
Two
do a square
negatives
root of a
make a
-9, can I evaluate a square root of a -9?
Square root.
No,
Square
I
root
can't
of
evaluate
3
that.
times square root of 3.
Number and
If I can't evaluate a square root of a -9, can I tack a negative on there and evaluate a negative square root of a -9? No, this thing it can't evaluate. So tacking a negative on there is not going to help me evaluate it.
No.
This thing you can't evaluate. So overall, if I'm looking at this thing, I believe this thing should be blanked out, right? I can't do this. Can I do a minus? Can I do a -4?
No.
Can I plug in any minus number, any negative number? So none of these negatives are going to work when I go and try to plug this thing back in. Now we are here. Can I plug in a 0?
Yes.
And if I negate 0, what does it become?
0.
It's still just 0. 0 is neither positive nor negative. Okay. And then the next thing, can I plug in a 1 to this thing?
Yes.
And if I plug in a 1 and then I negate it, what does it become?
-1.
Yep. I do a square root of. So make sure we're all on the same page right quick. Let me write out middle steps. Minus
the
square root of 1, right? Is what I'm
1
doing.
equals 1, and then you add the negative.
Yep, is a -1. So
Is
we're
a
doing the square
-1.
root first, and then we're tacking a negative on the outside is what this tells me.
That's the same thing for number 57. So we're adding the inside of the square root, and whatever that number is, then we tack on the negative exponent for it.
Afterwards?
Afterwards.
I think so. Yeah, I think
because the roots, it's always comes like how we say, grades or equals to 0. We can't do it like less or equals to 0.
Because 57, yeah, the negative was on the outside. Yep, that's it.
Right.
Can y'all see what I'm showing on the notes? I am sharing the right screen, right?
Yeah.
Okay. Y'all do see these graphs that I'm like drawing on. I was hoping. It depends how you share your screen sometimes. So I was like making sure I didn't hit the right thing. So this, if I square root 4, it's going to become what?
-2.
It's going to become 2, and then I tack a negative, it will become -2 overall. Yep. So 0. I think we're getting what? -1 here. This is a -2. We take a square root of a 9, it becomes 3. I tack on a negative, it becomes -3. So that's this one. This one doesn't mean tack a negative on the outside. And so what I believe that did was flip it about the y-axis. So we get that same sort of thing, but now instead of going up, it's going down.
So how do you do that with a long, like with number 57? So we so for 57, you do not need to graph it. Parent function. We just have to put the parent function for 57. That's
So
it.
57 was they wanted the instructions. So we're going to move left 5. We're going to take the original parent function, which is the square root function. We're going to move the square root function to the left 5 is what this thing tells me. And then the negative on the outside tells me flip it about the y-axis.
Yes.
Which was the same thing I have like here, right? If I put the negative on my outside of the square root, I'm flipping it about the y-axis. And I believe this one, when we put the negative on the inside, positive numbers on the inside are going to become negative. So what ends up happening when I plug in a positive number like 1, I'm getting a negative in my square root. Same thing here, right? I'm getting a negative in my square root when I plug in these numbers.
So you flip it, you move left, is a positive, and
But
then
if
with the negative, you flip it onto the y-axis, which
if I throw in a 0 into this thing, I'm doing a -0, still 0. That gives me 0.
yeah.
I throw a negative on the 1, it becomes +1, and I can plug it into my square root as a 1. This becomes +4. I plug it into the square root, it becomes 2, becomes +9. Plug it into the square root after that, and then it becomes a 3.
Gotcha. I'm sorry, because I know what she was saying. At first I wasn't understanding because 57 looked so much like number 8, you know, that I was kind of confused also. So but the but what we're asked to do is totally different from what this is, right? So because 57, you just want to move it to the left. You want to write it out, right? Use transformation holography. You just want to show what it is. Y equals square root of x. Then you want to write the information about it. Move function left, then flip it about the y-axis.
Yeah, so just writing those sentences is what they want for that one, basically.
Use transformation. So
just tell me what the parent function is and tell me what the transformations are. Yep, that's it.
How it, so it's just telling you want to know how it was transferred.